There are two special case binomials that we will deal with in this class. One of them is called the difference of two squares, or I just call it difference of squares. And in a difference of squares pattern, notice I've got the same value as my initial value and the same value as my second value, and the only thing different between these two binomials is one is plus and one is minus. So let's take a look at what happens if I would multiply this out. 2x times 2x is 4x squared. 2x times minus 4 is minus 8x. My inside terms give me plus 8x, and my last terms give me minus 16. The minus 8x and the plus 8x cancel out, which just leaves me with 4x squared and minus 16 because these two go away. Now this will happen every single time that I have the same values but a different sign in between. This is called the difference of squares pattern, because all I would have to do then is take my 2x and square it, and take my 4 and square it and put a minus sign in between. Notice 2x quantity squared is 4x squared, and 4 squared is 16, and so I would end up at the same answer as when I FOILed. These patterns aren't super important for our material this week, but when we start factoring polynomials, that's when you're going to really want to know these patterns, so keep those in mind for now. Again, the second special case is the perfect square trinomial. So notice here I have the same values first and second, but also the same signs, because this is the same as x plus 6 times x plus 6. So let's look at what would happen first if I FOILed. And if I FOILed, I would get x squared plus 6x plus 6x plus 36, which of course would simplify to x squared plus 12x plus 36. Now, my perfect square binomial pattern says if I've got a plus in between, then my three terms, when I FOIL them out, will be my first term squared. So using that pattern, my first term would be x. I would square it to get x squared. My middle term would be twice the product of the two, so x times 6 is 6x, and I would double it to get 12x. And my last term would be the second term squared, so 6 squared is 36. So notice when I FOILed or when I used the pattern, I got the same answer. It's exactly the same for a minus in between, except that this first term will end up being a negative instead. Or sorry, the second term will be a negative. So again, I'm going to square this, 16z squared. I squared the number and the variable. I multiply these two together to get 12z, and then I double it to get negative 24z. And again, when I multiplied, I actually got a negative there. And then a minus 3 and a minus 3 gives me plus 9, and that's my final answer. These are a couple for us to practice together. My first one, notice I have a different sign in between, and so this is the difference of squares pattern, which means I would just have to multiply these two together, and with a minus sign in between, multiply these two together, and that's my final answer. For my second one, again, I'm following my perfect square trinomial pattern of squaring the first one, doubling the product of the two values, and then squaring the second one. Here are two for you to try on your own, then press play to see how you did. My first example, again, I would multiply the two terms together to get 4x squared. A minus sign in the middle, 5 and 5 is 25, because my two middle terms would have canceled. And my second one is a perfect square trinomial, so I'm going to square the first value. I'm going to multiply these two together, and then I'm going to double it. And then I'm going to square the second value to get plus 9y squared.